Hi, we're Team 206 Yearn to Learn, and this is our BRG DP2 presentation. I'm Sean Egan.
I'm Derek Oster.
And I'm Christopher Caston.
What follows are the events that occurred in order to prepare and go through with our concept generation phase.
So just as the presentation starts, an introduction on what this presentation entails. First, we're going to start with some project management tasks just so we can figure out where we are and where we need to go. Then intellectual property. With the concept generation phase, we realized that we couldn't infringe on any existing patents, so that's what that's going to include. Then we move into concept generation and selection, and then from that we move into the FMEA, which is the failure modes and effects analysis of those chosen concepts. Then we move into some economic analysis to close it out, and then we conclude by saying where we want to go moving forward. So this is a Gantt chart representing the schedule that we have come up with for our BRG. Currently we are right here at this green line. As you can see, this looks very similar to the one that we had in our DP1 presentation, but the most notable change comes in this long bar. This represents the economic analysis task. The team recognized that this task can start very early and continue through pretty much the entire beef of the project. We realized that the ideas of economics and how much things will cost is going to be ever changing, so that's why we need to keep this task open for as long as possible. The other noticeable change is that we made many tasks parallel because we realized throughout this project there was just a lot of chunks of activities and decisions that we could work on all these activities at the same time to conclude one big chunk of tasks. So really just streamlining the schedule and extending economic analysis is the main difference in this project management task than the DP1. Moving into intellectual property, the team found a lot of patents that coincided with the BRG that we are developing. The one that we have highlighted is a tape suspended balance. This is almost identical to our second station, the teeter-totter. Thankfully, this patent has since expired, so we infringed upon nothing with this. However, it did open the team's eyes on just how scary it could be to have a concept that infringes upon a patent. The team realized that there was no patent infringements on what we were doing, and thankfully, none of the concepts that we chose infringes on patents. Now, Sean's going to talk about our concept development and generation.
So for our first station, as a team, we decided that we wanted to give the ping pong ball potential energy so that it could propel itself through the remainder of the stations. With this in mind, here are the ideas that we generated. A lot of them are similar. You'll notice we have elevator, Ferris wheel, ramp type ideas, a rotating coil. And the final one we came up with that we decided to produce was the elevator concept, trivia elevator, where the children would answer a trivia question, press a button on the Arduino, and if they got the correct answer, it would raise the elevator up maybe an inch or two. And they had to get a certain number of answers correct in order to raise it all the way up. And they want to try and do it as fast as they can. So it would reinforce basic math skills or whatever questions that the teacher, whoever's playing the game with the kids, wanted to pick. This is our mock-up right here, made out of cardboard. We'll talk about what went wrong with it in the failure modes and effect analysis, but on to station 2, we wanted to reinforce some more basic math concepts. So you'll see the ideas we generated over on the left. The idea we ended up going with, we called the seesaw or teeter-totter concept. It's pictured here as our CAD model and our design in class. It is a basic mass analysis, so the kids would have to balance the pipe in the middle so that the ball needs to roll down that by putting equal amounts of mass in each end of the baskets you'll see there. This would help with fractions and basic addition of numbers or basic multiplication as well. Now, but moving into station 3, we wanted to go with more problem solving because kids want a fun game. They don't just want to be playing math or doing math the whole time. So pictured here are some of the ideas we came up with for basic problem solving, kind of puzzles more. Hopefully they would enjoy these more and keep them coming back and playing more and buying more. This concept pictured here on the right and modeled here on the right is the Towers of Hanoi concept. It's an age-old game, but we kind of adapted it into a station for our BRG project, where the ping pong ball cannot roll all the way down the incline until all of the pegs have been moved onto a different platform, and then the ping pong ball would be able to roll freely. It's a mind game, it's trivia, it's fun, and it lets the kids learn about problem solving, basically. Now, each of these concepts, moving forward, we are going to have to integrate them better together. Right now, they're 3 separate ideas, and we need to make them one idea with 3 different entities inside of it. We're considering a possible 4th station in order to make the game more fun for the kids and make it a longer game. We don't want that game to end too quickly. We're going to be beginning prototyping starting next week. We already have good ideas of how we're going to be improving our projects based off the FMEAs we'll talk about in a minute. And we're really going to work on the details of our design. Right now it's been all ideas, but we're going to start getting into system level and then detail level design. But first, the FMEAs. So, none of our prototypes worked particularly well. Not prototypes, mock-ups, excuse me. But doing the FMEAs, we had a couple major takeaways. Critical system failure could occur on almost any of our parts breaking. So moving forward, we're going to focus on using durable and reliable materials in our BRG in order to ensure that if one part breaks, maybe the whole system doesn't break, or just no parts break at all. This is really important because nobody is going to want to buy our product unless we meet these requirements. And the connections between stations we have not really begun developing yet. Hopefully, as a group, we are pretty confident it won't be that difficult, but moving forward into system level design, that'll be a necessity. Up next, we're going to discuss the economic viability of our product with Chris.
So going into economic analysis, your intern learner will be asking DTEPs for a loan of exactly $1,666,806 million, as you can see right up here. The way we calculated that loan is we took all the outflows and annuities that your intern learner will have to be paying back over the first year to kickstart our project. We took all those, turned them back to present values in Excel, and came up with our value of $1,066 million. So essentially what we did is we calculated the cost of staff over the 3 years. We calculated how much it would cost to produce at least 50,000 BRGs a year at a production cost of $25. And we had our fixed cost per year of $11,250. Now, we used our allocation charts to figure out how much we would need to pay our employees per quarter. And for year 1, we figured out that we would have to pay them at least $40,000 per quarter. That's just an average of what we will be investing, and that came from our allocation charts of how many mechanical engineers we need, software, marketing. And then for year 2 and 3, it drops from $40,000 to $12,500. This is because Yearn to Learn doesn't believe that we will need mechanical engineers or software engineers at this time, because we plan to start selling our BRG at the end of the first year. So we need all this loan money essentially to kickstart in the first 4 quarters. As you can see here, we have annuities going out of $355,000, and that again came from adding up the cost of staff, the fixed cost, and also finding an annuity. As you can see on the $1 million loan, we found that annuity just in Excel. And we figured out if we wanted to pay back our loan over 8 quarters, so at the start of year 2, we would need to be paying back $218,000 per quarter. So we put all of that into our cash flow diagram, and then we added into it all of our profit, how much we need to pay back, and we actually figured out after quarter number 4 we're making profit. And in total, after the full 3 years, should be making close to $626,000 if our estimations are correct. Next up. So, in conclusion, we want to continue fine-tuning our stations. They are still a little rough, and we want to make more formal prototypes so we can see how things will fit together more easily, and so that they will be more sturdy. Again, create more durable prototypes. We want to start looking into more durable materials instead of cardboard. And then we want to finalize our 4th station, continue to maybe think of other ones, or to at least start our prototyping so we can get a head start on that. And then lastly, begin transition into our system level design and becoming more formal with our CAD models and really starting to mock up assemblies. Thank you.